So in this tutorial, I'm going to go through integration by parts. Now, it's generally used to integrate functions like, or the integrand, which is the function inside the integral. So the integrands, and they're fairly easy to spot. So they're x e to the x, x sine x, x cos x, x squared e to the x squared sine x squared cos x, or x to the n natural log of x, and also just natural log of x itself. So most of them are just some power of x times either e to the x of some form or a sine or cos function. So the formula is basically a rearrangement of the product rule. So the product rule says if we differentiate uv, we get u dv dx plus v du dx. Now if we integrate everything, this is going to become uv is the integral of u dv dx with respect to x plus v, the integral of v du dx with respect to x. Rearranging to make that the subject of it, so you get integral of u dv dx equals uv minus the integral of v du dx. That will become obvious. This formula, we'll use it the whole time, and it's good to lay out things on the right hand side of the page saying what u is and what dv dx is. Now, so I'm going to recopy that formula up here. You don't really need to know, there's no reason why they can't ask you it, but there's no reason to really know apart from that, in the rare instance it would come up, how this formula is derived. Now, the most important thing is what you take your u as, because you can't just think, oh, I'd fancy taking that as u. There's specific things, and I'm going to say L, I, T in that order. So firstly, if you have natural logs, take those as your u's. If you have I is indices of x, so that'll be x, x squared, x cubed. If you don't have natural log and if you don't have indices, then take the trig function as your u. So I'll start with probably the easiest one of the lot, which is x e to the x. So remember the L, I, T. We don't have natural logs here. We do have a power of x, x power of 1. So that's what I'm going to take as my u. So u equals x, and dv dx is e to the x. I really advise you to lay your working out on the right hand side in a little box that's shaped like this. So du dx equals 1, and v, if you integrate e to the x, you get e to the x. Don't bother adding c, you don't need to here. So is uv, so put that in a little box to make sure we don't go into that, is uv x e to the x minus the integral of v du dx. So beautifully, by taking the u as x, it's become a nice easy 1. So it's just 1 times e to the x, which is just e to the x. So our final answer is x e to the x minus the integral of e to the x, of course e to the x, and then you add your c at the end. and that's it. So let's do another one, let's do another similar one, x cos x. So here, u is, we don't have a natural log, we have a power of x, which is my x. So u is x, and dv dx is cos x. Oops. So du dx is 1, and v is sine x. So the integral of cos x is sine x. You may want to use the little circular thing. So sine, cos, minus sine, minus cos. Some people find that helpful. So if you differentiate, you go that way, clockwise. If you integrate, you go anti-clockwise. So cos integrates to sine. So is uv. Minus the integral of v du dx, and beautifully again, just as in the previous example, the x is differentiated away to 1, so it becomes minus the integral of sine x, which is x sine x. So negative sine integrates to cos, so plus cos x plus c, calling that negative sine. Now I'm going to do it twice. So now I'm going to do an x squared. Now with everything but ln, natural log to most people, or most people do say ln actually, you have to do it twice. So be careful about the negatives. So the integral of x squared e to the x. So again, u is x squared, dv dx is e to the x. So v is e to the x when we integrate, so du dx is 2x. I'll put that in a box to just, so do your working like that on the right, but do lay it out. Don't try and do it in your head because it just leads to errors. So uv is x squared e to the x. And also, when you're doing it in a box like that, what you can do is go, oh, which way do I want to write it? If it was a 2e to the x, I'd write 2x squared e to the x. So it saves a line of working as well. Do not do too much in your head because it leads to errors. Minus the integral of that times that. So 2x e to the x. So our integral already looks easier because our x squared has now become 2x, which is obviously easier. So we're going to do it all over again. So u is 2x, dv dx again is e to the x. So again, we're taking our u, we don't have natural logs, we do have a power of x, which is x power of 1. I'm calling u 2x, so u du dx, or u dashed, is 2, and v is e to the x. I have to say that some formulas rearrange and put v du dx on that side. Most go with this convention. But just if your teacher at school or college does the other way around, you've got to just work on it. Remember that then v is LIT. Or stick with my way. Your equals should line up usually, but this board is not very wide. So I'm going to bring my equals back a little bit. So it's x squared e to the x. Now remember, we've got this nasty minus sign. So let's put a big bracket here and do it all again using u's and v's. So 2x e to the x minus the integral of, and here we have it like 2e to the x dx, if you can, on the end of that. Now, what I do at this stage is I multiply the brackets out. You can do the integration first and multiply if you want to, but do it in 2 steps because negatives are so easy to get wrong. And you don't want to throw away marks when you've done everything correctly, but you've put the negative in wrongly because you rushed it and skipped a line of working. So x squared e to the x minus 2x e to the x plus the integral of 2e to the x. So that makes it just a lot easier. So x squared e to the x minus 2x e to the x plus 2e to the x plus c. So here is doing it twice with an x squared. But the only exception, x squared cos x, x squared sin x, you'd have to do it twice. If you had an x cubed with e to the x sin x cos x, you'd have to do it 3 times, but they shouldn't give you that. The only exception is when you have x squared natural log of x. That goes in one nice step. So I'll do that in a minute, but I think I'm going to do one more x squared with you, just with the constant sign. So let's do this time. We had a cos last time, so let's do x squared sin x. So u is x squared dv dx equals sin x. du dx equals 2x and v equals, so using our s c minus s minus c, differentiation goes that way, minus s minus c, apologize. Differentiation goes that way, integration goes that way. So sine integrates to minus cos. I'm going to box that off. So we have uv is minus x squared e cos x minus the integral of that times that. Now you can do this in 2 lines. Maybe I'll do it in 2 lines. So minus 2x cos x. So here is minus x squared cos x plus integral of 2x cos x. It's really nice to simplify in 1 line. It takes literally seconds. Do not risk losing marks by not just writing down 1 extra line of working. What does it take? 3 seconds? It's not a big deal. Maybe 5. But it's best to ensure, otherwise you're going to have loads of negatives floating around and you're going to lose marks. So here, I'll squidge this in here. Here again, we take our u as 2x, our dv dx as cos x. So cos integrates to sin x, and du dx is 2. So that's, you can see it goes from x squared to an x inside with a 2, doesn't matter too much about 2, and then it goes from the 2x inside to 2, so it just makes it easier every step of the way. So we go minus x squared cos x. As we've got the plus here, we don't really need the square brackets. So plus, so the uv on this is 2x sin x, write it in a nice order, minus the integral of 2 sin x, which is minus x squared cos x plus 2x sin x. Now here we've got a minus sin x which integrates to cos x. You could call it sine and brackets with a negative, but I don't think that's a massive step to make. So after saying do 2 steps of work on this one, I think you've got to pick and just think, look, it's not a big deal here. I've got a minus sin x and that integrates to cos x, so it's going to be plus 2 cos x plus c. Of course, that's, sorry about squidging it on. So now I have done most of the, obviously they can make it more complicated by sticking in a 2x or something like that, but you should be able to cope with that. Now we're going to do natural log of x's. So, drop my pen. We have got integral of, let's say it's an x squared natural log of x. So this is the exception. We must take u not as our x squared, but u is the natural log of x. And dv dx as x squared. Du dx is 1 over x. And v is a third x cubed. So it's uv, write it in nice order, a third x cubed natural log of x, minus the integral of v du dx. So many people, you can't imagine how many people go, well, I can't integrate that. No idea how to integrate that. Really, I would hope, here's a bit depressing, I would hope that you would be able to see, sorry if you didn't get this immediately, you just stick the third out the front, and x cubed divided by x is just x squared. So that's why it doesn't reduce down, it just divides away. Whatever the power of x is there, it just divides down. And so you get a third x cubed times the natural log of x minus a third times a third x cubed. So the answer is a third x cubed times the natural log of x minus a ninth x cubed plus c. Not many more to go now. So they're pretty easy to recognise what you can do with integration by parts. So it's x e to the x cos x sine x squared e to the x squared sine x squared cos x, or x of any power times the natural log of x. And that includes x to the power of 0. And now this doesn't look like it really should be integration by parts, because you're like, well, it's two things multiplied together. So what you do, again, you must take u as the natural log of x. And you simply take dv dx as 1. Now, in maths, they've picked u's and v's in this. Do write your u's and v's properly. I've seen so many times u and v. Those are almost identical. You will probably get those confused. Okay, so make sure that is a u, and if you get them confused, make that a v. They're terrible letters to pick, but that's the ones they've used. And that's the ones in the formula. So, du dx is 1 over x, and v is x. You can use your v dashed and u dashed if you want to. So, don't write it as ln x. It's so the beauty of writing out this, you can choose the way in which to write it, way round in which to write it. So, x times the natural log of x minus the integral of 1 over x times x, in whichever order. Now you hopefully will see x ln x minus the integral, that divides away just to give you 1. X times the natural log of x minus x plus c. So that is, again, so therefore if you get a simple natural log of x or 3 ln x or whatever, it's product rule. Sorry, it's integration by parts, which is the sister of the product rule in the, which the kind of the use of the product rule in integration. So finally, these are nasty ones, these ones, okay, is e to the x times cos x or sin x. You've got to do this twice. I might run out of board space, so bear with me. You need to write down the left-hand side. Keep your working really neat if you can. It's really important if you misread your own handwriting or whatever, and it's important to see the left-hand side on this. So this time we don't have a natural log. We don't have an indices of x, any index of x squared, x cubed. We have trigonometry. So that's what I'm going to take as my u. So our du dx is minus sine of x, and our v is e to the x. So we start by saying e to the x cos x minus that times that. And I think it's fair enough. Hopefully you'll be happy with me saying plus e to the x sine x dx. Right, so we've got to do it again. So we have here, this time u is sine x and dv dx is e to the x. So du dx is cos x and v is e to the x. Hopefully you can read my scruffy writing there. That's a u. So we get e to the x cos x. As we've got a plus there, we don't need to put the square brackets in. So, what you need to do is write down the left-hand side. E to the x cos x dx equals. So, you get e to the x cos x plus e to the x sine x minus the integral of e to the x cos x. This is rarely asked, this question, but if it does come up, then you'll know how to do it. So that is the same as that. So the reason we have to write down that side is if we add that to both sides, we'll get this. So therefore, I'll halve everything there. And just whack on a plus C at the end and you're done. So make sure on these ones that you very rarely get, you write down the left-hand side, that's the main part of it. Keep your layout really neat, box it up on the right. I'm happy for you to use u dashed, v dashed if you want to. I just generally use du dx. And as I say, some schools have that on the left-hand side. So what's important is this letter here, the u, or if that's on your left-hand side, the v, you take it following the LIT. L for natural logs. If you don't have natural logs, I for indices of x, which means x, x squared, x cubed. If you don't have that, then take the trigonometry as your u.